Hello and welcome to GP, not 104. Oh, okay, that's a typo. Um, yeah, I'll need to readdress that. GPE340, even though the milestone opened up and said GP 104. That was not correct. Um, yeah, okay. So currently, there's only really going to be a couple changes to what was previously done, and since I pretty much aced all of the previous components of it, I'm just going to go ahead and do a quick demo to cover the first couple. Player health / life count. So the additions to the UI that they're looking for, as you can see when I pick up the gun, it displays the graphic up here. We have the life count up there. You see the health bar over the enemy. You see the drop there. You see that I still walk around. You can see some of the stuff I've already significantly added for the final. You can see my unique mechanic that has my enemy agents. As you can see right there. When I picked up the blaster, you can see that it changed the graphic for it. And now when I pick up the machine gun, you'll see this change again. Now watch, when I pick up the blaster, it'll change again. Huzzah! You can see the wacky health bars I have that orient on the enemy. You can see the ammo counter down here, and you can see me pick it up, how it increases the amount of ammo. Yeah. So, there's the health count. I'll kill this guy, so he'll spawn a weapon. I'm probably going to kill another one because currently I'm not spawning weapons on the field. Deal with this guy. Okay, so now you can see there's actually 2 weapons on the field. So it'll be interesting, because I'll show that the player still ragdolls when they're killed, because you've already seen me ragdoll the enemy a couple times. Wait for it to update the AI behavior. Hey, knucklehead, update your AI behavior. Oh, there it goes. It's trying to find me. This is so funny. Yes, here I see the health bar going down. You can see the player ragdolls. Gotcha! So the player ragdolls when he dies. Here's the pause menu. Ooh, I like the battle rifle more. You can also see the light, which is actually part of the milestone 5 requirements. It wasn't really specified what you had to do for the light in the canvas shell, so I made flashlights. As you can see, I have the shells for the bullets already, and I have the impact glyphs. You can see the light probes very faintly. You can see the composite shadow here, and you can see more shadow there. And mainly that's because there's actually 2 different light sources here, that the shadows from the 2 of them kind of cancel out. Because you can also see the light from the flashlight and how it actually projects the shadow. So what I have going on here is just regular light projection, it's also combining shadows off of multiple probes. Alrighty then. And here's the game over screen. Okay. Boolean pause, game pause, weighted drops. Right. Well, you saw me killing him and you saw him dropping things and me picking those up. So everything for that is covered. Let's go ahead and clear these up though. Recently I've been having a lot of errors with like the GraphEdge node and Unity in general during the boot up. I think part of this is because of the antivirus software that I'm running, because it doesn't impact gameplay at all. It just doesn't like certain arguments. But while we're in the inspector here, as you can see, even though it's paused, getting this to work was kind of interesting, and updating in particular the materials on this into being high definition rendering packages, rendering pipeline materials. That was a bit of a challenge, but once I got it done, you can actually see that it's able to project shadows, overlapping shadows, and it's even able to, as we'll see over here, this is not baked by the way, it's even able to do additive and subtractive light probe factoring, which is above and beyond even for the final project. Right here you can also see the spotlighting that I did with the barrels here. And I'll show you, the barrels are kind of interesting because they are rigid body. So I'll just go ahead and bump into them to show you that they're actual real physics objects in the game. And you can see the particle effects of when I hit them. Bonk. Le bonk. And then those don't move anymore ever since I made them static. But yeah, as you can see, the light probes are actually additive. So when the flashlight on that gun is spinning around, it actually adds the various light inputs to one another. So we have the weapon display, which when we go back here and we look at the canvas, it's right here. Let's go ahead and do a quick dive into that. So gun image, which is what it is, I have it set to the transparent, and since it culls the material that is not there, okay, so when you have a sprite, and I'll just go to the sprites real quick. So here are all the sprites for it. So when you have this sprite, which is what I use for the higher damage rifle, the blaster, and you have all this grayscale stuff here. When it gets added into the gun image here, all the stuff that's in grayscale gets culled from the sprite. So what we end up doing is we end up recoloring this obviously white thing to being a kind of transparency blue, because the purpose of the UI is to help the player play the game, not to stop them from seeing what's going on. So obviously what I'm going to do with the gun image is I'm going to alter its delta here, so, or alter its alpha here so that it's transparent and you can go ahead and see through it during the gameplay. The health system is very straightforward. It's a modified slider with text over the top of it. There's nothing really remarkable there. So we just took the health feature from one of the first stages of the product, or one of the first stages, and we just went ahead and added a slider bar to it. Now for the enemies. The enemies are kind of interesting in the fact that my baddies have the health bar attached directly to them, so it destroys when they destroy. And I just like this because when it was doing the graphic user interface, nullifying them was a bit processor intensive. So when I was looking at how to optimize, one of the ways that I found to optimize was to actually just attach the health bar to the bad guy instance to begin with. And as we can see here, the baddie container itself is actually an empty that holds the model, which is this part, because if I shut that off, you'll see that that contains almost everything else. But if I shut this off, you'll see that only takes care of the health bar and the canvas and all its other grand and sundry. And there's the weapon container that we use in order to hold the weapons transform on it and set the parent and whatnot, so that it points the weapon in the direction that it's facing. Because the weapon, interestingly enough, doesn't actually get instanced on the bad guy when they pick it up. The interesting thing about my weapons is that the weapon that you have here, when you pick it up, you're picking up that actual weapon. Right now I don't do anything more with that, because I could have just made this a prefab or a pickup, and then when you pick it up, you just go ahead and make a new one. But yeah, that's how that works. Instead, I go ahead and make it so that when you run over the gun, you actually pick up that particular gun, which is different. So let's go to navigation just to show the fact that, yes, NavMesh still exists. Yes, NavMesh excludes the glidable. These no longer work as they originally did because they've been marked as static. So I can no longer shove them around as level physics. But that's mainly to help with navigation. You can still see the bad guy spawner here. Bad guy spawner still has the pointy arrow. The addition for this game is going to be the player spawner, which is here, as you saw me spawn from repeatedly, both at the start of the level and every time thereafter. I could throw in more bad guy spawners, but there's not really much of a purpose for me right now to demonstrate multiple bad guys working at the same time. There's just no added benefit. Let's go ahead and go back into the bad guy container here, because when we get back into here, you will be able to see the spawn list menu, the weighted spawn list menu. There's all of the wonderful AI, and here's the drops and the waiting for the drops. So we have Sapphire Rifle 2, Sapphire Crate 2 Open B, which is kind of interesting because it's this ammo box that you saw him spawn previously. But going back to here, and then you have Sapphire Rifle 1, Sapphire Rifle 2, and Healing Pickup. Healing Pickup's there. Sapphire Rifle 2 is the blaster, the heavier of the two. The Sapphire Rifle 1's the machine gun, spelt G-U-N-E. And that's pretty much the only changes. We added a couple more items to the event logs just to make everything else work right. So you see the drop an item is actually now a part of the on-die function. Or not the on-die function, the on-die event. And that is pretty much how it works. We'll cover the code a bit later. So, UI currently shows it. I did that. UI health and life count. I'll go ahead and show the logic for ending the game. That's actually in the game manager. Game pause. I've showed that it paused. I'll go ahead and show the code. Weighted drops. I'll go ahead and show the code for that. Pause menu. UI menu allows players to change settings, quit, or resume the game while paused. Yes. Well commented, and then the scope for everything. Alright, so I'm just going to go ahead and pop back to my main scene here. Save stuff since I clicked around a bit. And go ahead and open the game manager script. Loading up Visual Studios. Okay. So here in our game manager, you'll notice that I've commented next to nothing. Make player spawn. Make player spawn right here is very simple. And as you can see there, that's hard quits the game. So for the player UI and the game over, this itself is not actually the game over script, but it does change the timescale here. So it sets it to pause and it changes the timescale, which this one also does, and this one also does. This one turns it down to 0, this one turns back up to 1. It's pretty concrete. This is the scene manager. So the scene manager is very straightforward. Load start scene, load start scene, load scene, and then this is just an array that works off a given instance of the game manager, which there should only be one. Highlander. Very Highlander. There should only be one game manager. And this works off of what its currently self-assigned game manager is in order to change the scenes. It's very straightforward. The only main difference between mine and maybe somebody else's is that I'm not entering in a hard scene name for the scene. I'm actually, if we go up here and look at the variable I'm using, I'm actually using a scene array. So in the inspector, what I would do is I would load the scenes directly into the array, rather than just using the name for them, because I can use the .name extension in order to get the name for them from the particular instance. So the main benefit for this, even though it's definitely not a part of the class, is I wanted to experiment with the way that you would load procedurally generated scenes into a game to reduce the in-between level loading when you're doing procedural generation, because there's a way to procedurally generate scenes using a seed algorithm, but it's much harder to name them. But if I use this array method, I can just load these procedurally generated scenes into the array as they're created, and then load them when the previous scene is completed. So this allows for procedurally generated scalability, whereas using the regular names or using a hard-coded name for the scene would not. This also allows me to increase or decrease the total number of scenes in a game without having to resort to some very messy back-end database manipulation. Which, I mean, it is still doable. It's just, to me, this strikes me as being neater. Because then all I would have to do, instead of having this, I would just have to do int this level to load. And then I just put that here in place of this 2. and that would let me load however many scenes I have, and I could get what my maximum number is just by doing these scenes.length. So it lets me have a lot more scalability in development and instantiating a scene, because I can use a blank scene, then I can use a procedural generation and then mark it as a new scene and save it and then load it through this. Or I can just even have it as a non-static dynamic and just create it on the fly, load it into the array to hold it, and keep on keeping on. Since I have the don't destroy on load, I can actually use the game manager itself to store the data for the scenes, which is neat, yeah. And that's using those is pretty much my above and beyond mechanic, aside from the light and the HDRP and the multiple light probes and the shadow blending, which I'm probably going to use for the final. For this one, I'm going to go ahead and say that my unique method of dealing with the scene loading is my unique mechanic. Pause menu. So over here in player UI, here's going to be the UI that's responsible for choosing which graphic to post. So the sprites themselves are going to be stored on the sprite array, which is a serialized array that's private. So I can actually change the color of the backdrop or whatever else while I'm at it. But what it does is it goes ahead and it looks at the weapon class, looks at the weapon name enumerator, and then checks to see what the current assigned weapon designation is, and then it chooses that graphic. And if there isn't currently an assigned sprite, or if there isn't a currently designated weapon type, it goes ahead and nullifies the sprite, which is why when we boot up the game, you don't see the blue square, because I have other logic set up in there so that when this when there is no weapon, this blue square won't show up. That's very nice, and it's literally right there. So it'll only enable it if the current sprite that's assigned to the graphic is actually not null. Because if it is null, then it disables it, so it doesn't show up. All this one really does is it checks to see if there exists a player inside of the scene. Because if there isn't a player inside of the scene, then it tells it to go find him. And that's just really nice, because when I kill the player, I actually destroy the entire player object as well. I don't just I'm not just teleporting the player back to the starting point and resetting the functions. I'm actually destroying the entire player object, as you might have seen during the earlier videos. Game pause, boolean flag for game pause. Game pause is right there. Public static. There's the flag. Initially sets to false because it starts in runtime. That's just really for the sake of easy demonstration. So all the scene loading's right there. Everything else is already up. Weapon display. Well, my weapon display not only shows the sprite that I've chosen for the weapon, but it also shows the amount of ammo that they have, and the weighted drops. So yeah, now on to weighted drops, which I think is actually a part of AI controller. Is it part of AI controller? I think it's part of AI controller. I don't know. Let's go back over here and check real quick. No harm in looking. No, it's not part of AI controller. It's part of not the face. Okay, not the face is my hostile pawn's equivalent of health. Because my base class for any destroyable object in the scene is actually damageable object. This one. Not the face is going to be my humanoid AI specific AI script. Because as we can see, like right here, this is where I also assign the audio clip that it plays when it gets hit in the face, basically. If you're having a hard time keeping up with this, it's because I've already mostly completed Milestone 5 stuff as well. There's only like one or two things in that I haven't fully implemented already. So it's kind of like in more of a transitory between 4 and 5 than anything else. This just updates HP. There's nothing really special about that. Okay, so down here we have the choose item. And the script for it is extremely straightforward. So, some of the weights. So then what, some of the total weights of all the items in the drop list, I haven't really done anything extremely special. It just adds up all of the drop weights for everything, and then it sorts through them in order to determine what the maximum choice is going to be. And instead of using the CDF C#, I used Unity Engine random.range to get the number, simply because it's a lot less processor intensive than a binary search tree. And I used a distributive scaling weighted method selection choice instead of the binary search tree, simply because the binary search tree is a little bit slower. Yeah, but that's pretty much all that there is to that. So what it does is it runs through the weight sums in order to determine, alright, when it decides what the range is, it takes the maximum value of all the weights combined, and then it selects a number between that and the maximum number. So it's like a spinner dial, but we're always starting from a 0 origin. So you flick the spinner, and it stops somewhere between 0 and maximum number. And the way the weight works is that the bigger weight a given number has, the bigger the chunk of the spinner it takes up. So there's a higher choice, there's a higher probability for it to land on that. I mean, mathematically, there's going to be some predisposition because it's not real random. There's no such thing quite yet on computer as real random when it comes to these kind of random range stuff, but it's a good approximation. Let's say that. Weighted object for me is very unique due to the fact that it actually exists pretty much solely within the class that it's used, which is fun. And here's the array for the weighted objects for the drops. So that's also fun. I don't really use events so much for this. I probably could have set up, like, say, event public event on drop to trigger some drop AI scripts. Here's the thing that actually destroys the enemy. So you can see right now I have it hard-coded to 4.6. That's just because I like seeing the ragdoll laying there. And it's very convenient for me to make sure that when I destroyed it that the ragdoll was working properly, being able to let it linger there for almost 5 seconds solid. So that's just stuck as it is because it was convenient. Drop an item. Drop an item is really convenient and it's set up this way. So it can actually only drop one item one time, and I was having an issue with this because it was dropping every time the hostile mob got shot even after it had already died, or it was attempting to call the method multiple times for other reasons, numerous, that I went ahead and added in this logic to make sure it could only drop one, and it could only instantiate once. And this is this part of the code is actually really unique because this is the only thing that gets called for the drop. Because as soon as it goes ahead and decides, okay, I'm going to drop, it kicks this one. Pretty much as soon as this one starts up, though, it goes ahead and triggers the sum weights. But that's just part of it spawning. So it's kind of a sweetheart deal when it comes to everything, because you see right here on start, it sums the weight, then it does a base startup, then it silts the health value, and each update it re-updates the health value, and it does the base updates for what's actually damageable object. Damageable object is the base class that both the player and the bad guy inherit from. So the code is extremely straightforward when it comes to doing damage, taking damage, and updating. It makes my life very simple when it comes to doing everything. The main reason that I'm getting those errors in the first scene is because I've commented out the audio play script for the player, because I got sick of hearing the player get shot during the bug testing. And that's the only reason it's throwing those errors, is because it doesn't have the, it doesn't specifically have this on it. So that's why it's giving me hardship. But I mean, the collision stuff and everything else still works, because obviously you can see the player die. It's just that since it doesn't have this part on it, it doesn't destroy the bullets after the player gets hit, because that and that got commented out because the sounds were annoying me for the development cycle of it. But that's pretty much all there is to that portion of it. So weighted drops, game pause timescale. Okay, so just for, there's me changing the timescale for the game over. There's me creating the background for the game over. There's me triggering the event for on resume. There's me triggering the event for the on pause. You can see everything is instantiated through this game manager .onpause.invoke, and that is largely just to control the state of the game and have it based off of only a single game manager. And a lot of that just has to do with the whole public static effect and being able to access these members publicly. Requires that I have a specific instance of the game manager that I'm referencing, because otherwise it causes problems. And the compiler goes, bleh, die, go off yourself, if you try to do it without specifically referencing a static instance of the game manager. And that does everything. Well, thank you for your time.